Today we're going to delve into the world of electrical safety by discussing plugs, fuses and the role of the earth wire. Stay with me till the end and I'll show you the correct way to choose the right fuse for the plug for your appliance. First up, let's talk about fuses. Fuses are safety devices that are designed to protect electrical circuits from overloading and overheating, which could lead to electrical fires. This is the circuit symbol for a fuse. Inside the fuse there's a thin wire that's designed to melt and break the circuit if the current through it exceeds a certain amount. This helps prevent damage to the appliance and helps reduce the risk of electrical hazards. The current rating on the fuse tells us how much current can flow through the fuse indefinitely without it melting and breaking the circuit. A plug is what connects an electrical appliance to a power outlet or socket. It has three main components: the earth, live and neutral pins. I have another video showing you how to wire a 3-pin plug and I'll leave a link to that in the description. Let's look at the wires that connect the live, neutral and the earth. The live wire is brown and I think of it as the wire that we use to carry the energy to the appliance. The energy is supplied thanks to an alternating potential difference or alternating voltage, same thing. What do I mean by that? When we get our energy from a battery, it is supplied as a direct current. That means the voltage remains constant, hopefully supplying us with a very steady current. The UK main supply is supplied as an alternating current. That means the current goes from positive to negative to positive to negative. You get the idea. It supplies a power equivalent to a 230 volt DC supply, and it fluctuates from positive to negative and back again 50 times per second. For that reason, we say the UK main supply is 230 volts AC 50 Hz. It actually peaks at around about 325 volts. Make no mistake, the live wire is incredibly dangerous and contact with it can kill you. The alternating supply of the live wire actually alternates with respect to the neutral wire, which is blue. Please don't go thinking the neutral wire is safe though. It's there to complete the circuit and can carry a significant current. So what about the yellow and green striped earth wire? The earth wire is an essential safety feature in plugs and appliances. Its primary purpose is to provide a safe path for electrical current to dissipate in the event of a fault. That fault could be something such as a short circuit or just a loose wire. If a fault occurs in an appliance with a metal casing and the live wire comes into contact with that metal casing, then the earth wire provides a safe route, a low resistance route for that electric current to flow straight to the ground. A large current will now flow through the live wire. This will cause the fuse to melt, breaking the circuit and cutting off the power supply. Don't go thinking though that having a fuse and an earth wire means that you won't get electrocuted, because that's definitely not the case. A better component for this is an RCD, a residual current device, sometimes called an RCCB or a residual current circuit breaker. RCDs are designed to detect a very small leak in current, and they can work very, very quickly to break a circuit. They undoubtedly save lives, but they aren't foolproof. None of the safety features I've said today are guaranteed to protect you from electrocution. Just bear that in mind when you play with electricity, or don't play with electricity. Before I tell you how to pick the correct fuses for appliances, please take a moment to support the channel. Like, subscribe and comment even. This all helps my channel and encourages me to make more videos and more resources. Back to fuses. Hopefully you've seen the equation that power equals voltage times current, or P equals VI. As we have seen, in the UK the voltage is 230 volts. We can find the power rating of an appliance by looking at a sticker, which is usually located on the back or underneath, like on this kettle. This is my wife's kettle. She's going to get so annoyed if I keep nicking it. The kettle has a power rating of 2,300 watts. If I substitute this in the equation, I get 2,300 equals 230 times I. Rearranging, we get 2,300 over 230 equals I, so I equals 10 amps. The current taken by this kettle is 10 amps. There are many fuse values you can get, but the common ones in the UK are 1, 3, 5 and 13 amps. So the best one for this kettle would be a 13 amp fuse, or should I say the plug for the kettle. If I picked a fuse with too low a current rating, then it would melt too easily and the appliance just wouldn't work. If I chose a fuse with too high a current rating, then it wouldn't offer much protection at all. Most appliances that involve heat, such as irons, toasters and electric fires, require a 13 amp fuse. TVs, desk lamps and laptops tend to need smaller fuses. Check out the description for a link to my website where there's some useful practice questions and answers. And, oh, there it is. Watch this video.